Hello, welcome to Chapter 7. This chapter is about random variables. And we have an example right away. Let x represent the number of heads that occur when a fair coin is flipped 3 times. X is what we consider a random variable. And we've been using random variables since Chapter 2, and we haven't really defined what a random variable is. Now let's look at all the possible values for x. Well, we can have 0 heads, 1 head, 2 heads, or 3 heads. So this right here is called a probability distribution, where we list out all of the possible random variables, all the possible values for the random variable, and then the probability that each occurs. Well, the first thing we need to do is find out what this looks like. And a tree diagram is the best way to do that. On our first flip, we can either get a head or a tail. From there, we can get a head or a tail from each of these. And then on our third flip, we can get heads or tails from each of those. So let's get rid of this. So all of the possible values, we can have a heads, 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 or you flip heads 3 times. You can get heads, then a heads, then a tails. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. And tails, tails, heads. And then finally, all tails. So the probability that you get 0 heads, that will just be this one. So that would be 1 out of 8. 1 out of 8 is 0.125. So we don't have that one anymore. So the probability that there's 1 head, but occurs here, here, here. So that's 3 out of 8, which is 0.375. The probability that we have 2 heads will be there, there, and there. So that's another 3 out of 8, so another 0.375. And the probability that all 3 will be heads will just occur once out of 8 times, out of your 8 possibilities, so it'll be 1.125. So this is what we call a probability distribution. We have the values for x and its probabilities. A random variable is a variable whose value is a numerical outcome of a random phenomenon. So we want to find out how many times something occurs. A discrete random variable, x, has a countable number of possible values. The probability distribution of a discrete random variable x lists the values and their probabilities. So the probability of getting x1 is p1. The probability of it becoming x2 is p2, and so on. Now there's 2 requirements that we have to satisfy. The probability of anything occurring is between 0 and 1. And the sum of all the probabilities, so if we add up all of these values, they are going to equal 1. Now, here's an example. North Carolina State University had the following grade distribution. Now they're saying an A is a 4, a B is a 3, a C, D, and this must be F. So what's the probability that something is greater, the grades are greater than 2? Well, 2 is there, so greater than is to the right. So what we'd have to do is take 0.43 plus 0.21, which is 0.64. So there's a 64% chance that the grade is going to be greater than a C. Probability histogram. This is a histogram made with random variables and their probabilities. So if we wanted to draw, let's change this to 3, because that's what we did earlier. So if I wanted to draw this histogram, on this side we'll have the probability, and this is number of heads. We can have 0, 1, 2, or 3. And the probabilities, we can have pick a scale, I think 0.125 would be a good scale for this because it's eighths. And to draw this, we're going to go up to 1.25 over and down. And then we're going to go up to 0.375 over and down. And then 2 heads is the same. And 3 heads is at 1.25. So this is our probability histogram for flipping heads with 3 tosses of a fair coin. Now we had discrete random variables, and now we have continuous random variables. Now with a continuous random variable, there is an infinite number of solutions for the sample space. So with our discrete, there was just a particular number, say this. Our values were just between 1 and 4. But with our continuous random variable, we can have 1/4, we can have half of that, which is 1/8, half of that, which is 1/16, half of that, which is 1/32, and you can always half those numbers for an infinite amount of times. And so there's an infinite amount of numbers between 0 and 1. So if we want to find the probability that our random variable is between 0.3 and 0.7, what we do is, since this is a uniform distribution, the probability of each occurring is the same. What we do is we want to find the area between 0.3 and 0.7 in this density curve. And between 0.3 and 0.7 is 0.4. Now if we want to find the probability that x is greater than 0.3, that would be 1 minus 0.3, or 0.7. Probability that it's less than 0.2 is just going to be 0.2. And the probability that it's between 0.4 and 0.9 will just be the difference, which is just 0.5. Now, a continuous random variable doesn't have to be straight across. It could have some density curve that looks like this. And our definition for a continuous random variable is a continuous random variable x takes all the values in an interval of numbers. The probability distribution of x is described by a density curve. The probability of any event is the area under the density curve and above the values of x that make up the event. Now each individual score has a probability of 0. So on the spinner, the probability of getting exactly 0.5 is 0. And this is hard to wrap your head around, but if you think about the probability of getting 0.5 is 1 out of the sample space, which is an infinite amount of numbers. Now, that doesn't really make sense to have a denominator that's infinity. So the probability is essentially 0. Alright, the normal distributions are probability distributions because the normal distribution has a density curve. Now we have to think back to our Chapter 2 knowledge. If a sprinter's race times are approximately normal, the probability he has a z-score that's above 1.3. So if I draw my standard normal curve, where the center is at 0, 1.3 and above would be out here. So if I want to find the probability my z is above 1.3, I go to my calculator and hit second variables, or second bars. You do a normal CDF between 1.3 and some large number to represent infinity, and the answer should be 0.0968. If you want to find the value below 0.8, here's 0. 0.8 is less than 1, maybe here. And so below 0.8 would be all of this. So without even typing these in my calculator, I would say somewhere around 60, 70. And what it is 0.788. So the probability that my z-score is below, so that's less than 0.8, is 0.7881. The probability is between negative 0.5 and 1.2 would be somewhere in here. So I just do a normal CDF. My low number is negative 0.5. My large number is 1.2, and hit enter. So that's probably my z-score is between a negative 0.5 and 1.2. That's 0.5764. So I've already drawn in the normal curve to show what each one represents. Make sure you draw your normal curve. Alright, now the distribution of golfers' 9-iron shots are approximately normal with a mean of 110 and a standard deviation of 9 yards. This can be written with that big N, meaning normal distribution with a mean of 110, standard deviation of 9. Find the probability he hits the ball more than 120 yards. So we're finding the probability that x is greater than 120. This is the same probability that my z-score is greater than 120 minus, alright, I'll try that again, 120 minus 110 divided by 9, which is the probability that my z-score is greater than 10 ninths. So when we're drawing this, we have two options. We can either draw the x values or the z values. If I want to draw my x values, my mean is 110. My standard deviation is 9. So if it's greater than 120, that would be somewhere over here. So it's going to be a pretty small probability, probably like 10-ish. I don't know, let's look. So the normal CDF, we're going to go from 10 ninths to a large number, and that is 13%, 0.1333. So about 13% of the time, the golfer will hit the ball more than 120 yards. Find the probability that the golfer hits the ball out of his 9-iron less than 105 yards. So that's probability that it's less than 105. That's going to be the probability that his z-score is less than 105 minus 110 over 9, I believe. Yep. So that's the probability that his z-score is less than negative 5 ninths. So if we draw this out, if I want to do the standard normal curve this time, where 0, 1, negative 5 ninths is going to be over here, and we're going to go less than that. So I'd say maybe 25% as a guess. Let's see how it goes. So we're going to go from negative infinity all the way up to negative 5 ninths. So that's about 28%. So 0.2893. Alright, if a golfer's trying to hit the ball on the green and he is 102 yards from the front of the green and 114 yards to the back of the green, what's the probability the golfer gets the ball on the green? So that's the probability that his x value is between 102 and 114. That's going to be the probability his z-score is between 102 minus 110 over 9 and 114 minus 110 over 9. So that's going to be negative 8 ninths to 4 ninths. And it looks like that's about 0.4846. So about 48% of the time, I get the ball on the green. So if this is my mean of 110, my standard deviation is 9. We're going to go from 102 to 114, and this is the area we are representing. That looks like it's about 50% of the data. Alright, another question altogether. A survey of 400 undergraduates shows that 12% would turn in a fellow student for cheating. To find the true proportion of undergraduates, we have to know that if we repeat this many times, it will be a normal distribution with a mean of 0.12 and a standard deviation of 0.016. What is the probability that what is the value but it's probably the real value for the probability differs more than 2 percentage points. So we want to know if this is anywhere close to the national, so or the true mean. So it's going to be between. We want to see if it's between 0.10 and 0.14. So that's like a plus or minus 2 percentage points from that value. Now to do that, we want to find the probability that my z-score is between 0.10 minus 0.12 over my standard deviation and 0.14 minus 0.12 over my standard deviation. Now that's my probability. I have to take out my calculator for this. Negative 10 minus 12 divided by 0.06016. That's 1.25. So we have negative 1.25 and 1.25. So we want to find the probability that our values in there. So it's going to be, if this is my z-score, that's 1. It's going to be a little bit outside of 1 standard deviation away. So it's going to be quite a bit. So I'm going to do from negative 1.25 to 1.25. That's 78.87%. So that's 0.7887 is the probability. All right, hopefully this helps you out with this assignment. Try to do this homework. Good luck.